Here's a fundamental fact of number theory. Every number can be expressed uniquely as a product of primes. So for example, 8 can be written as 2 times 2 times 2, or just 2 cubed. And 12 can be written as 2 times 2 times 3, or 2 squared times 3. And 21 can be written as 3 times 7, or 7 times 3. And we can only do this in one way. I can't write this as like 5 times 2 or something like that. Like there's no way to introduce new primes or anything like that. If I'm going to write 21 as a product of primes, it's going to involve the numbers 3 and 7 and no other prime numbers. What about what's the prime factorization of 1012? How can I go through that? So I'm gonna focus this video like almost exclusively on how to find the prime factorization of 1012. I'm gonna do it very slowly and do all of the possible steps that might go through your head when you're doing this. So to figure out what the prime factorization of 1012 would be, you just kind of go through the list of primes and see which primes go into it, and then just factor that out, right? So let's list our primes. So 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. Okay, so we just kind of go through this list and see which one goes into it. Why don't we like look for the composite numbers, like 10? Like why don't I see if like 10 goes into this number, or 6? Why don't I try to factor out a 6? And the reason is, well, if 6 is a factor, then 2 and 3 are both factors, and so if you're going up the list, you already would have found the prime factors that came before that composite number, right? So if I were doing 15, if I found that 15 was a factor, then I would have earlier found that 5 and 3 were factors. So we only have to look at the primes. So that's good thing number one. Now, if you notice that, if you notice right off the bat that 15 is a factor of it, then hey, that actually saves you some work, because then you'll know that 3 and 5 are factors. So if we're finding the prime factorization of 150, well, we know that 10 is a factor, and we know that 15 is a factor, so we can factor it more quickly that way and just kind of go down from there. But we don't have to, is the point. Okay, so let's go down the list. Is it divisible by 2? Well, yeah. The divisibility tests for both 2 and 5 are pretty straightforward. You just check the ones digit, see if it's even, or see if the ones digit is like a 0 or 5 to see if it's divisible by 5. So those are easy, right? So we can see that it is even, so it's divisible by 2. We can factor out a 2. Right? So our first step, we could notice that this is just 506 times 2, so we're factoring out a 2. And then notice, hey, this is still going to be even, so we could factor out another 2. Or let's say that you actually know the divisibility test for 4. So the divisibility test for 4 says, look at the last two, or the last two digits, like the ones digit and the tens digit, and see if the number made by those two digits is divisible by 4 or not. So 12 is divisible by 4, and so 1012 is going to be divisible by 4. Okay, so we could actually just jump straight ahead to factoring out a 4. So 4 goes into 1,250 times, and it goes into 12 3 times, so we have 253 4s here. All right, what about 253? So we're done with 2's. We factored out a 4, which is really 2 squared. Maybe it should write this as 2 squared here. What about 3's? Well, here we can just add up the digits, 2 plus 5 plus 3, and we would get 7 plus 3 is 10. So see if that number is divisible by 3. 10 is not divisible by 3, so 3 is not going to be a factor. So we're done with the 3's. We already figured out the 5's. The 1's digit is not a 0 or a 5, so don't have to do anything with the 5's. What about 7? There is a divisibility test for 7. It's, in my opinion, rather complicated, and I never memorized that one. It's in the book as a problem if you are curious. I'm not going to spend too much time on it. I will just divide this number by 7 and see what I get. So 7 goes into 25 3 times. Okay, we get 4 left over. And then it's not going to go evenly into 43. It goes evenly into 42, and then we get a remainder of 1. So 7 is not going to be a factor here. Okay. At this point, I'm starting to get worried. Like, I am not, when I'm doing this problem, I'm not sure whether or not this is going to be a prime number. So I don't want to divide this number by 11, 13, 17, 19, 23, 29, 31. I don't want to, like, keep going. I want to eventually know, like, when can I stop? Like, what's the last number that I have to divide by? I want to minimize the amount of work that I have to do, right? So this, like, 2 squared times 253, this might be the prime factorization. We might already be done, right? So how would we know whether or not we're done? Well, there's one fact in the book that says that you look for the number. So take the square root and see, like, what two whole numbers that this is going to be between, or equivalently, what two numbers would, like A and B, would, like, 253 be in between when you square them. And so you might notice that 253 is a little bit less than 256, which is 16 squared. So 253 is a little less than 16 squared. And so it's going to be bigger than 15 squared, which is 225, right? So the last number that we would have to check would be the first prime, or the last prime before 15, which would be 13, right? So we only have to check 11 and 13. So if 11 and 13 both don't go into 253, then that tells us that 253 is going to be a prime number, and we're done. This is the prime factorization. Okay? So I'll spoil you. That is not going to happen, but let's find out why. So let's do the divisibility test for 11 next. So the divisibility test for 11, let me demonstrate this with another number. Here's 123,456. How do we know whether or not this number is divisible by 11? I like to think of it as you have, so like every other number is going to be blue number, and then the other numbers are going to be red numbers. Okay. So if I add up all the blue numbers, and then I add up all the red numbers, and then I take the difference of those two numbers. So the blue numbers add up to 9, and the red numbers add up to 12. And if I subtract those two numbers from each other, I get 3. And whatever this number is, if this number is divisible by 11, then the original number is divisible by 11, and vice versa. If it's not divisible by 11, which 3 is not, then the original number is not divisible by 11. So this number is not divisible by 11, right? So if we got like 22 right here, or 11, or even 0, then this number would be divisible by 11. Now 253, let me make this black so I can, whatever. So these are going to be the blues, this will be red. So the blue numbers add up to 5, and the red numbers, there's only the 5. And so if I take the difference, I'm going to get 0. And so is 0 divisible by 11? The answer is yes. Yes, 0 is divisible by 11. Every number is a factor of 0 because any time that you, any number, you can always write 0 as a multiple of any whole number, right? 11 times 0 is equal to 0. 17 times 0 is equal to 0. So we're basically factoring out like an 11 from 0 or factoring out a 17 from 0. So any number is a factor of 0. Okay, so yeah, 11 does go into 253. Passes the divisibility test. And so let's factor that out. 253, let's divide that by 11 to see what our quotient is going to be. So 22 and 3 goes into 33 3 times. We get a remainder of 0. And so this will be equal to 2 squared times 11 times 23. And this is our prime factorization.